Okay, this application problem is actually one that we solved earlier, and we got the solution was x1 was 1, x2 was 6, and the minimum cost was $9.50. But this time we'll solve it using the dual method, and if you need to, go ahead and pause the video and refresh yourself on what this problem's about. But since we've already set up this word problem, I don't think there's any reason for us to go through that part again. But it turned out that when we set this problem up, the original problem was a standard minimization problem where you're minimizing c equals 2x1 plus 1.25x2 subject to these three greater than or equal to constraints. So that means this is a standard minimization problem. So then you write your coefficient matrix from the constraints: 300, 100, 900, 400, 300, 2200, and 100, 200, 800. And then from your objective function you have 2 and 1.25 and then 1 for 1c. And then if you transpose this, then you'll get your first row will be 300, 400, 100, 2. Second row 100, 300, 200, 1.25, and your third row 900, 2200, 800, 1. And so from this you'll get this dual that I have here, and so you can see now that the dual problem is here. And so the bottom row gives me the objective function 900y1 plus 2200y2 plus 800y3 equals p, and we're maximizing that. And then the first two rows give me the two less than or equal to constraints. So I have 300y1 plus 400y2 plus 100y3 is less than or equal to 2. 100y1 plus 300y2 plus 200y3 is less than or equal to 1.25. And then don't forget your non-negative constraints. Then you take these two constraints and you add the x's from the original problem to them to create equations, and you get take your objective function, move all your terms over, and they become negative. So you have so your objective function is written with the negatives here, and then you're going to put that in a tableau form. So the first, I didn't label the top, but really this column is the y1 column, this is the y2 column, this is the y3 column, and then this column is x1, this column's x2, and then this column is for p. So the first equation from the initial system gives me 300y1 plus 400y2 plus 100y3 plus x1 equal 2. And the second one gives me 100y1 plus 300y2 plus 200y3 plus x2 equals 1.25. And then the last equation, minus 900y1 minus 2200 y2 minus 800y3 plus p equals 1. And then of course you have to determine your pivot. So we're actually going to pivot on this column because negative 2200 is the most negative indicator. And so you kind of get some weird numbers here, but you have to do these quotients. 2 divided by 400 is 0.005. And then 1.25 divided by 300 is about 0.0042. So it looks like row 2 is the smaller of the two quotients. So we would pivot on row 2 there. And so you'll see we'll pivot on that 300. Okay, so now the row operations you're going to need to do this pivot is you're going to have to multiply row 2 by 1 over 300. And then after you do that, that'll make that a 1. So then you'll multiply this row by negative 400 and add it to row 1 to cancel the 400. And you'll also multiply this row by 2200 and add it to row 3 actually to cancel the negative 2200. And then you can do it and check your work here. This is the tableau that I got once I did those three row operations. And now notice I still have a negative on the bottom row. So what I've got to do is, that's going to be my pivot column where that negative is. And then you're going to take 1/3 and divide it by 500 thirds, and that gave me 0.002. And then take 1 over 240 and divide that by 1/3, and that gave me 0.0125. And so the smaller of these two would be the 0.002. So that means we would be pivoting on the first row, and there's your pivot element for the 500 thirds. So to get to do the next pivot, since we're going to pivot on this 500 thirds, you're going to multiply by the reciprocal of 500 thirds, which is 3 over 500, and of course that'll make that a 1. So after you multiply everything in this row by 3 over 500, then you want to multiply the row by negative 1/3 and add it to row 2 to cancel the 1/3. And then after that, multiply row 1 by positive 500 thirds and add it to row 3 to cancel the negative 500 thirds. And that's these three row operations here. And then once you do that, then you're going to get no negatives on the bottom row. And so you can see now, like I told you in the beginning, if you look at the bottom of the x1 column, you'll find the solution for x1 in the original problem. So the solution is 1. And if you look at the bottom of the x2 column, you'll find the solution for x2, and that solution is actually 6. And then if you want C, remember C has got to be the same as you got for P here, which is 950. So the minimum value for C is $9.50.